So I'm presenting Mangrove, that's a decentralized exchange with new features. So it's based on an order book. That's not new. That's kind of the traditional model in traditional finance, and it's been the dominant model. Not so on the blockchain, as you know. And from the taker point of view, or from the point of view of price aggregators, really this is just a price curve, price volume curve. It offers nothing special. The DEX is aimed at the makers, the people actually providing liquidity. So here we actually provide a distinct, unique features that we think are breakthroughs in the field of DEXs. So the very first one is simply explained. It's that we do not lack capital. So differently to usual order book based or actually AMMs based DEXs in DeFi, people as a maker ask you to actually provide liquidity, which means concretely you have to lock it in, right? And people talk about total value locked, we don't. And the second thing, if you're ready to juggle with credit lines, is that you may actually don't have to provide capital at all. So you can have zero cash market making strategies. I'll explain that. Now, the third thing, and that's super important for people who track price processes accurately, is that we actually have a mechanism to defend your prices against price motion, sudden hikes and jumps in prices. So you don't have price exposure or inventory risk, as people call it sometimes. And this is, so we'll call it here, in between us, defensive last looks. It may not be the final word for this. And this is particularly targeting market makers, because they really need to be careful about prices. And then the fourth feature is really another way to rephrase the first one, is that there is no exclusivity. Meaning, since you're not actually providing the liquidity, you might as well publish it multiple times, right? So, and that's kind of a liquidity amplifier mechanism. So by the way, there is, as you can see at the bottom right, there is a Telegram channel that we just created, and if you want to chat, get some kind of discussion, technical or not, later on, please just connect to this. We'll be watching it, and we'd be delighted to talk to people and get feedback. All right, so these are the features. Now, the next thing I want to say, and I think it's important, or maybe it's not, depending on your point of view, but if you're a builder type, this is interesting. Actually, everything here follows. So first of all, it's not a closed list. We expect many more features to emerge. Actually, we didn't start with that list of features. Some of them we actually found on the way. And actually, everything follows from one single, simple technical idea that we have implemented in the code, and that's that idea. So the idea is that differently to normal DEX, you're not providing liquidity, so what do you provide instead? Well, so you provide code, or rather a callback address to some code. And second idea, we do not want to know what that code is. You provide whatever you want. It's a complete black box. So whatever strategy you can come up with, we don't ask you to follow any kind of requirements, any kind of structure. It's a bit like a flash loan mechanism. You take the money, you have to return it by the end of your transaction. If you don't, then we revert, right? So it's very much in the same spirit. And since we're not asking any guarantee that your code is actually correct, it may not be correct, it may just be clumsy, it may be buggy, or it may just be malicious. So we ask you to provide in F some provision that will cover for the gas expenses that you may incur to the taker. So that if you do nothing of interest to the taker in the book, then at least he's not paying for your gas expenses, right? Else the maker else would live like a parasitic being that's actually pumping gas from the taker to no avail. So an offer is, as usual, a volume that you're ready to give, and then a volume that you're asking in return, plus a gas requirement, which is some upper bound on the amount of gas that you're projecting to use. It may be a very large upper bound, and then code, or address to code. Plus a provision that's covering your gas requirement at what gas price? Well, at the mean gas price as dictated by the current platform. So this is the same. And now I have to be careful. So this is how we see people could actually use this platform on the maker side. But we have to agree that this is not prescribed by us. So if you want to do other things, then you're welcome. This is how we see a reasonable way to sequence the way the matching engine wake-ups will be processed by the script. So to not be confused, I'm going to call the code to which you give a callback address a script. But it has to be also very clear that this code is on-chain, right? And this actually is key for the rest. So you have a dedicated piece of code that's managing a bunch of offers on the DEX, on multiple pairs of the DEX. And that I'm going to call the script. It's a bit of a loose denomination. It's just to be clear between us. So here's how we see a reasonable way that that script could be organized in 3 easy steps. So the very first event is that the matching engine is actually waking you up and says, okay, you said you wanted that much, I have that much, or maybe some partial fill. And so what do? So the first thing the script does after receiving this match from the Mangrove engine is, asking itself, the script is wondering, deliberating about whether that's still a good price. Because the last time the script was alive was maybe at time t0, and now it was time t1. And maybe the picture of the world that the script had at time t0 was good enough, and it could formulate some kind of offer. But now at t1, it has drifted. So maybe it's not willing to actually go with the deal anymore. So the question here the script is trying to answer is, should we go or not go? Am I going to renege on my offer or not? So to make a good decision about this, you're going to collect signals from the book and signals from the on-chain environment where you are to see whether the prices on-chain now have drifted, and potentially off-chain signals. I return to this. Of course, they are more expensive, and so there's a trade-off here. And at that stage, so your defensive price module has decided whether to go or not go, and if it goes, then we go to the second stage, which is so for example, little piece of code, markup piece of code, you're actually going to compare the price you're offering, or you were offering at T0, with the current Uniswap TWAP, for example. And if you find that you're underselling by more than 1%, you'll say, no, I'm not doing this. I'd rather pay the little compensation fine to the taker than actually run my order. But suppose you do actually want to do it, then you go into the second stage of the rocket, which is to source the liquidity. And for example, so this is where the no capital thing or the no capital locked thing gets into play. You don't actually have the money inside the DEX, you're going to have to source it. And so one simple way to do it is, for example, to have it in some kind of savings account. It's by compound, it's earning yield, and it's just now that the matching engine has woken you up that you say, okay, give me my liquidity. You redeem on compound. There are more clever strategies, there's an entirely new novel strategic design space, but this is about the simplest thing you can think of. Of course, you can also redeem liquidity from an AMM. Everywhere where your savings are actually earning yield, you can bring back at that time and not before. And then the third stage, so I'm simplifying a little bit the mechanics here, but the third stage of the rocket is to actually update your offers. Because you have taken new information at the first step, you know more about the prices as they are now, so maybe you should update all the offers that are under management by your script and have a better, more accurate picture of the current price state. So this is the refresh offers. And I'll also comment on this. So for example, you've just read at the first stage the current TWAP Uniswap price, so maybe you can just update it in all your offers. On the other side of the book to begin with. So if you're underselling on one side, you're overselling on the other side, which means that you have offers that are waiting, rusting offers, as people said, that are waiting on the book, and they're not going to be taken because they are just too expensive now. So bring them back a little. All right, and of course there is this possibility of failing, and so there's this preconception that failing is a bad thing, but actually if you look at traditional finance, failing can be a very efficient way to handle capital. And there's a lot of literature about strategic fails in traditional finance. At some point, it was 8% of the orders were failing on New York Stock Exchange. So we don't consider failing as a bad thing. We consider failing as something you have to control. You have to sandbox, and that's what we do here. But failing is actually a very efficient way to, if you're never going to fail, then maybe you're a bit too inefficient. All right, so there is this strategic fail option, or last look, or protection against price exposure. All right, so so every single of these 3 stages connects to the features I was explaining at the beginning. So let's label them. So this third one is liquidity amplification, or ghost liquidity. And here I'm using the bad name, or the name that traditional finance people have given it to, which is ghost liquidity, and which is something they'd love to do, but they're a bit afraid of doing. Here, no problem. It's under code control, so we can do ghost liquidity. And that's what I'm going to exemplify third. Then the second thing is defensive pricing. Defensive pricing is actually very subtle because there's a difference between the price processes you measure them on-chain and the ones that you measure off-chain. They don't have the same cost or price, if you will. So the price of on-chain is not the same as off-chain, and the timescales are different as well. So this makes it a subtle strategic space to navigate, so I'll give you examples. And then the third thing is maybe the most obvious is the liquidity sourcing. So this is the first example we'll look at. Okay, so let's start with no capital locked, or how we can source liquidity. So here I'm using, so this is not a strategy per se, this is a piece of a strategy that you can use as a module that's going to source liquidity, but with a lender-only behavior. All right, so it's just a savings account, and essentially what the strategy can do is move things from your local money to the savings and back to your checks account. So we start with, and I'm not telling you how. This is part of the really strategic module. This is just how you move capital around. So here you start with 100 DAIs on hand. This is your local money. It's in your pocket, right? So real cash. And then you have 900 here, which is deposited as collateral on Compound, say. And it's collateral that you'll never borrow from, right? It's purely putting it there to get returns. And now you have a Mangrove event, and there's a taker that comes and wants 800 of your DAIs, and 800 is carefully calculated so that it's a volume that you have, because you offered 1,000. Here you're not doing liquidity amplification, so you don't have to borrow, it's fine. But you have only 100 in your pocket, so you have to go to your savings account, and that's what the transition does here. It's going to go in the savings account, and at the end you get 200 left on your savings, and in return you have your F, which you also, as you can see here, you also deposit here in your savings account, right? So I withdrew a bit of DAIs and I put back a bit of F. And the prices are a little optimistic. I think it's now cheaper than that. So this is the pure lending strategy. One simple instance of generating returns and having your money that's in your resting offer, not locked, but earning. Now something more ambitious. Oh, no, sorry. So this is different. This is a bit mathematical. I think it's interesting. I try to be quick but clear. So we actually did a little simplified mathematical model of this. There's obviously a contentious thing here, which is that, if it costs nothing to go between the savings and the checks accounts, then you'll do it all the time, and you can have everything, 100% of your capital just earning, right? But then the local money is never enough, so every time you have a match, then you have to run to your savings account, and that costs. So on the x-axis here, for both rows, you have the relative price of the interest rate and the cost of moving between your two positions. So it's how much your capital is earning in the savings divided by how much it costs to move from the savings back and forth. So the rebalancing cost, right? So moving capital has a price, especially on Ethereum. It can be quite costly, so you have to be careful. And so the surprising fact, so this is extracted from 2 weeks of Uniswap data, 100,000 actual orders on those 3 respective pairs. And the question we asked to the model is, okay, you get this time series, what is the percentage of local cash that you need to keep, after which you are going to push to the savings. What's the optimal one? It can be, it's easy to show that, you know, it's a convex problem, so that's the best solution. And here it is. And this diagram actually gives you the solution. Have I pressed something bad here? It still works here.
So he's managing.
Someone is doing something? Yeah, okay, cool. So anyway, I can continue over the slide. So the surprising discovery is that no matter how expensive the rebalancing gas costs are, you can actually get 80% of the return just by having a phi max, so a max fraction of, thank you, a max fraction of 40%, sorry. So the optimal policy for that time series is that you will never let the amount of local cash that you have in die or at, in both it's actually quite symmetric, exceed 40%. So when you're in excess of this, you're going to push to a savings account. And when you're under zero, then like we saw in the transition, you're going to pull from that savings account. And so this, in a way, you know, if you could say this is a strategy that's going to beat Uniswap no matter what the gas costs are, because you know, and there's no magic. Actually, the reason is that the distribution of size orders on Uniswap, because of the penalty for slippage, is extremely narrow, and will hardly ever, in relative size, exceed 1%. Okay, so well, I'll do it without slides, unless we get slides. So we finished that first, exploring that first set of features, which are related to, you know, managing liquidity. So now we can move over to the first stage, which is price defense. So price defense, so the principle is very simple. You're going to collect on-chain information and try, for example, Uniswap TWAPs, because they are public variables that you can get for cheap, and you're going to compare what you thought was the spread which you posted, which you based your offer on at time t0 with time t1, which is now, right? And if you find that you're underselling, then you'll say no. If you're overselling, you're always happy, right? And then, so the interesting question here is the following. So there are two beautiful slides that talk about this, but let me do about slides that may actually be better even. First thing, the script is not managing just one offer. It's managing maybe a multi-band offer on both sides of a pair, but it's actually maybe managing an entire set of pairs, right? Typically an AB, BC, CA triangle. So this means I'm managing actually 6 different half books, and in each one of them I have maybe 3 offers, right? Because I'm discretizing a price curve. So maybe I have up to 18 offers that I need to manage. So now, so this is simple, but actually shows in the maths, and it's fun. Each time you wake me up on one of these 18 different offers, I have an opportunity to take the information and bring it back to all the other 17, right? So in my sleeping pattern as a script, the random time between 2 instances when I'm running is going to be roughly scaling as the typical interval, which depends on the spread, complicated question, but divided by the number of offers I have under management. So there's so in traditional market making optimal control problems, you manage your spread, and you kind of find some kind of trade-off between your inventory risk and how often you want to be taken. Here there is an additional element in this trade-off, which is the amount of information you can collect. So you have intuitively you have another reason to be closer to the top of the book, which is to be taken more often. But now you can also mitigate this, or you can control that typical wake-up times, or that typical delay between the T0 and the T1 by multiplying your offers. So this is kind of fun. So that, you know, that's one thing. Now there's another discussion to be had which is really interesting, and I had cool data to show you. So we've been tracing back. Okay, let me take a step back. So this is purely about on-chain collection of information, and of course we want on-chain collection because it's cheap, right? Relatively cheap. It's just reading a variable. Now, the price mechanism or the price discovery process doesn't only run on Ethereum. Of course, it runs on the kind of the crown of centralized exchanges around, and they are operating on a very different time scale. And so, actually, Uniswap is essentially a zombie compared to, I don't know, Kraken or Binance. Not the Binance chain, right? The Binance exchange. And so maybe they operate on the, you know, millisecond time scale, and, you know, by construction, the physical interblock time on Ethereum being what it is, this is really super fast compared to the evolution of the price process on chain. So what does that mean concretely? It means that it may be, and this is what we measured by looking at the data, it may be that what the chain believes or what Uniswap believes the price is actually not a very good approximation of what the rest of the world believes is the price. So you have these two timescale mechanics, and what we did is we calibrate, so we downloaded the data for, I think, for the entirety of June. So the execution price of Binance on one of the three main pairs that we've looked at, I can't remember which, I think at USDC. And then we looked at how often there is a significant discrepancy in both directions, because we're on both sides of the book, between the price as read by Binance and the one that's actually read by Uniswap. And this is important because when I'm collecting on-chain data, then maybe it's not accurate. So how often, as a market maker with a little infrastructure and a bot that can talk to my script, how often do I have to press the emergency button of my script, of my bot, and tell the bot to tell the script that the Uniswap price is not actually something it should read anymore? And the answer, so we calibrated, so there's a standard model for financial data that's not predictive, but that's measuring key characteristic of financial time series, which is called the jump diffusion process. And so we calibrated, and these are, you know, well understood, as you can imagine, techniques to do this. We calibrated that, and the answer is the statistics is not very robust, but one robust observation, which we could also do just with our eyes if we had the slides, is that the jumps or the Poissonian component of the jump diffusion is actually has very low intensity. What does that mean is that you have to press the button very rarely, maybe once a week. And then it's a completely different ballgame, right? Because I'm ready to do something expensive if I'm, you know, trading large volumes once a week. That's okay. What I don't want to do is to do it once a block, right? So this is the second question. And now I'll go to the, so I don't know if you're following the outline of the talk anymore. So we talked about sourcing liquidity first. Then we talked about collecting information about price and making a good price decision, including off-chain information. And now we're going to talk about ghost liquidity. Ghost liquidity is very simple. Say you're trading on a triangle ABC, and you have a bunch of A's. You can post your A's on both AB and AC. And the sequential nature of the engine will make it so that once, if you're taken, let's say, on AB and you're offering 100 something A's, I guess, then, and that's the total amount you have, then you can volume adjust the other offer so that you're never in the red, right? So the next offer will not find what people in traditional finance, and again, it exists in traditional finance, it's called an overfill. You don't want an overfill, right? The funny thing is that, so we've talked not just to DeFi people, but we've talked a lot with traditional finance people, and you can find correlates of all that the Mangrove is actually allowing you to do. It's just that it's a much more level space of exercising all those ideas that have been around for a long time. And of course, you have composability. For example, you see a concrete manifestation of composability is the liquidity sourcing strategies that I've just shown. All right, so I'm going to conclude. Let's summarize, right? So first thing, we have a new DEX. It's really breaking the rules. You don't have to provide liquidity. It's, you can use DeFi, the DeFi blocks as a backend, you could say. And that's something you can't do in traditional finance, right? You can't actually, or you can do it in a limited way by borrowing from your own exchange, but you can't borrow somewhere else, right? So here you can. So this is the no locking of the capital, or the very low requirement on capital if you're ready to juggle with credit lines, playing with compound and AVE constantly to just finance your strategies. So that's the first point. Of course, this is how. So if you think of it, what I've explained here, all the trade-offs of the strategic space, the ones we've seen. Those trade-offs will play out very differently depending on what the EVM-compatible substrate chain is. So if we deploy on Ethereum, then you'll have harsh conditions. It's slow and expensive, and so the type of strategies that you want to deploy, the market making you can do, is restricted. Although I've shown you the example where you can beat Uniswap, so this is already something. Now, if you move to something which is more like an L2 and is both faster and cheaper, then the strategic space unfolds and you have many more opportunities. And in the limit where gas costs are zero, then there's a lot of those trade-offs that just disappear and you have full strategic command. So, okay, so in particular, you could do this zero cash market making, which is something like the people, market makers are doing in traditional finance, or in centralized exchanges, except that they're exposed to a really heterogeneous bunch of interest, credit line constraints, whereas it's far more homogeneous and competitive. Number one. Number two, ghost liquidity, which is this liquidity amplifier thing. And number three, and we spend a lot of time on this, how accurately do you have, how much do you have to pay in the end to have an accurate tracking of the price processes. So these are the three things. So now what comes next? So the first axiom we pursued was, there are evident axioms like, best execution, things like this, that the book structure gives you for free. But the first thing we said, we want black boxes. So that's something we may come to actually relax, because so Mangrove is just for spot markets, right? What does that mean conceptually? It means that whatever the matching engine is trying to create, a match and some kind of transaction, at the time it's executed, then it's finished. There is no time extended relationship between the maker and the taker. But if you think of credit markets or credit line markets or options, that's exactly what it is, right? There is a time extended relationship between the two parties. But and we are very interested in moving to those kind of markets, like interest rate markets. We've been talking extensively with another French DeFi project called Morpho, or another one called AP Wine, where they are getting into this time extended thing. For that, we have to change a little bit something in the design. We have to not adhere to the completely. Okay, cool. All right, let's see what the talk actually was. Okay. This was the lender-borrower one. And this is actually funny. Defensive pricing. This is what you didn't have to look at. I think that this is the 2 time scales data. Look, I'm diving on this kind of anomaly. And here I see that Binance is severely, shifted compared to the red price process, which looks almost constant, right? Because we're at a time scale where it moves very slowly, and so this is some stuff I've said. This is the technique we use. This is the ghost liquidity diagram. This is the dependency of. This is my last slide. All right, so Blackbox is something we may actually want to modify. There's another thing which we are really ready to modify, which is that at the moment we have a Mangrove doesn't talk to your script unless it actually runs it. So you never run a script unless it's actually, set to motion by the matching engine. But why not? And also other questions of the same type. What's the type of information that's available from the book, not from the chain, but from the book to the script when you wake him up? So that will depend on, we're going to organize market maker workshops, try to understand how they think, what kind of strategy they would like to deploy, and if there is additional piece of info that they like to have, maybe it will enrich the engine. That doesn't really change much to the most of the code. These are important modifications that we can make to the code easily. And then the final thing is that the prices do not include the gas costs. So I'm not sure that's directly translated from French. So I think we're showing gross prices. I don't know if that's what you say, not net prices. And so that means that this seems a reasonable model if maker pays the gas cost, not the Mangrovian cost of matching, but the idiosyncratic specific gas costs to finance his price defense, his liquidity sourcing. But okay, this is to discuss. And so I'm finished. Please, direct any question you'll have after those. I don't know how much time we have now, but to this Telegram, and it would be really good to get return, reactions, feedbacks, suggestions, and so on. Thank you for your attention.
Actually, we have a lot of time because it's the lunch break afterwards, so we have unlimited time for questions.
You don't have to ask questions for a long time, but you may, apparently. Yeah?
Like outline like the structure of the contract and like how like the whole transaction goes from like the user sending the call to like the router and how that goes through the matching. Like what exactly when a user sends like I guess also what parameters is the user sending to the router and then how is the router deciding like which order to fill for the user?
Do you want to take that, Adrien? Maybe?
Yeah, sure.
Yeah, okay, cool.
So
Adrien is the lead dev, so he knows more about the code than I do.
So when the taker comes in, and let's say they do a market order, you just have the offers that are already sorted. And at this point, the offers are just these volumes and this pointer to a piece of code. And then one by one, all the offers are executed. If they succeed in providing the liquidity at the required price, so this is Blackbox, okay? The Blackbox code is executed. Now, if they don't succeed, then they are penalized, so we take from their provision. If they succeed and there is still some volume left to fulfill, we go to the next offer. So this is the first pass. And then there's a second pass, because there's at some point offers want to reinsert themselves in the order book. And in this first pass, it has to be reentrancy locked. But once the order is complete, then you recall them again, and you say, okay, now the order book is accessible, you can reinsert yourself. And you have a memory of the offer you just executed. We sent some data about what just happened in the previous call. Is this clear? Okay, cool.
Yeah, I think so. I simplified a little bit when I described like the processing order on that very first diagram. So that refresh offers thing actually comes, so when the matching engine climbs up the book, it will push every order that succeeded or not actually on the stack. And then when the volume is filled, then it will go back down and call every single offer and say, do you want to update something? So there is a little bit between this and that. There's actually a disconnect, and you go back to sleep for the time for the matching engine to actually fulfill the taker's market order, and then you'll come back. And actually, so okay, and a little game theoretic oddity here is that if you have the best price, then you'll be called first, which means that you'll be the last to update, which means you can look at what the other players have made, which is kind of fun because it means, if you're the best, then you have a little kind of a self-accumulating advantage. But, just be better than the best and you're good.
Thank you. I like the idea how you bring order book, but as a DeFi building block. But I have questions, maybe stupid, sorry. If you have a lot of orders with equal price, for example, but blockchain has like limited capacity. So how are you going to order this transaction? Because like your bot will be order this execution, and what happened with transactions that not able to go to this block. So how you decide this? Like it's like MEV inside MEV, or like I don't know, because it depends.
So there are two issues here. There's how much gas you're allowed to spend within a block.
No. Imagine you have like 100,000 transactions that match. Like you see that it might be executed, but there is no chance to include this into the blockchain. How you will order what transaction should go and what should like postponed.
Okay, so we are not doing anything about scaling, and we take the substrate as it is, right? So if it's slow, then the miners are solving, or you could dispute whether they're solving it in a fair way, MEV, but they're solving that problem for us. We're only concerned of finding a transaction that's a market order, and then we just serve it. And so there as well, you have a restriction, which is the size of the block, but then it's up to the transaction to not ask for an amount, to not exceed that size. Anyway, it will not run. So I think what you're asking is a question about the substrate on which the Mangrove is running. And if it's very restricted, then we'll have to. We'll take the takers. What you're saying is there may be a very large demand for actually sending orders to a given pair, and it's not going to be. It's going to be congested, but that's not our mechanism. That's the underpinning mechanism of the chain. Do you want to say something else, Adrien? All right. So I think another way to put it is the point you're making maybe is we'd better move to something which is faster, like Cardano. No, I'm kidding.
Thank you.
May I have a question? Yeah, probably a stupid question too. At which point the matching happens? So where do you have like some bot that does the matching, or
no,
or the maker pays for the gas that?
Thank you. So it's a bit like the talk from Masha Mousavi yesterday. So the book is, it's a frequent batch auction that she's doing, but so it's slightly different because here it's a continuous auction, but it's similar in the sense that everything is on-chain. There's nothing off-chain. Maybe the strategists will like to be partly off-chain, and that's what we discussed, a bit like the Hummingbot talk, if you've seen it, right? But here, differently to Hummingbot strategists, you can actually delegate some of your IQ and strategic intelligence on the chain. And that gives you a lot of the advantages that we discussed. So the entire, everything is on chain. Your strategy and the order book, everything is on chain.
But like someone has to send the transaction that actually does the matching. So the question is who it is? Is it taker who submits? Yes. So
taker,
it's taker
or price aggregator. Like this is so. Like I said. So an exchange is a two-sided market, right? So if you go from the taker side, nothing new. It's just the ordinary mechanism, except that it's composable. So you can be a contract and and behave like a taker. That's fine. It may be useful. Maybe a certain pair of the Mangrove will actually call another pair, and so the maker of a pair will be a taker of another one. That's entirely possible. So it's possible. But in a way, it's nothing novel on this side. It's on the other side that we provide the breakthroughs.
I see. Thank you.
You said all the orders are on chain. So what happens, or how do you prevent it from becoming very gas inefficient if I change orders or cancel orders, etc.? Because everything will be.
Very good question. So there's this kind of preconception that comes from traditional finance, really, that the only way you can interact with an exchange is by cancel and updates. So you have a change signal, you're observing everything you can, You aggregate signals in a kind of a proprietary way on your servers. You have a big infrastructure. Maybe you pay a very hefty sum every month to be co-located with the exchange, and you try to make that loop as short as possible. But the only way you talk to the exchange is cancel, update, cancel, update, cancel, update. That's essentially what Hummingbot is doing, right? And unsurprisingly, because the people are coming from traditional finance. Here, the unique thing about the Mangrove is that you don't have to be close to the exchange. You are inside the exchange. We let your script run at the time it is matched. You cannot be front-run, right? For example, if you have good price sources that are not manipulated by the taker, then you can just renege on the order. So it's a very special way to think, and so it has far-reaching consequences. And one of them is the one that I explained here, which is that you do not have to bother about having accurate prices from the outside world, which would be update, 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 more than once a week. And that's not expensive, even on Ethereum, right? Now, having said that, all the models we've had, they're instructed by data. We are not ourselves strategists, right? So we don't really know whether the market maker actually will hit the sweet spot and be able to extract value in this way. Yeah, so it's how to make money in 3 easy steps, right? You know, you may wonder whether gas prices actually are going to be too punishing on Ethereum for that scheme to work. But we're not totally married to Ethereum. We like to work with other blockchains that I'm not going to mention here. No, I'm kidding. No, EVM substrates are totally interesting, and right now there are EVM substrates that are very cheap on gas, and they are fair targets for us. Although they are less DeFi rich, and since at the middle step we use the DeFi as a back end, if there is nothing there, we are limited for another reason. We can still do ghost liquidity, for example, which is the reason I was showing it to you. That's a strategy that exists even if you have no DeFi.
Thank you very much.
I can comment quickly
yeah,
a little thing.
Go ahead.
So yeah, I said that I talked to traditional finance people. So I was telling them in a way to try to capture their benevolence. I said, all these ideas here, they're not really completely entangled with decentralized finance. If it's maybe we could go and talk to a standard exchange and try to Euronext, I don't know, New York Stock Exchange, Chicago Mercantile Exchange, whatever. They have, for example, the Chicago Mercantile Exchange has something called a non-firm quote with a price improvement. That's something you can do with the Mangrove, and it's kind of fun. So you can say, I did this, but no, you change your mind, and then you change the price. It's very, so the way I would phrase it is that traditional finance has been trying to do this, but they didn't have a DeFi. So they couldn't do it. And there are other reasons, obviously. So, the people, so I was talking to a big trade fund here in Paris on Monday. These guys are the scientists, the scientific traders. They're really good. And they were really totally enthusiastic about this traditional finance thing. So a lot of the ideas here are not just things that have correlate in traditional finance, but the new ones would be something we could actually bring back there. And then, if we believe Julien Bouteloup and his, view from the future that trad finance and decentralized finance will kind of converge in some way, then it can be useful to have this kind of a double-sided discourse to make it to where we want to be. Thank you.
Thank you very much.